Okay, good news, bad news of the day.
Good.
What do we want first?
Bad news.
Good. Bad news. Okay, so we have to start like an entirely new unit that is completely foreign to us. Okay, we haven't done anything with solving quadratics before.
Ew, that sounds scary.
Good news, right, so that does seem a little bit scary. The good news is that the two that we are looking at today are at least super easy. So the work that we're looking at today isn't very difficult. It kind of gets a little bit more difficult as we go. Okay, so the topic that we're actually looking at this unit, the whole reason why we were talking about radicals.
Wait, will we have a test with radicals on it?
We will have a test with radicals on it, but there will only be a few of them because you'll see radicals show up in everything that we're doing. Okay. What is a quadratic?
Something with 4 things.
It would be tempting to pick 4, but it's not.
Is it just like 2 things?
It's a degree of 2, so an exponent of 2 in it. Okay, that's our highest exponent. Our objective this unit is going to be to solve quadratics. So up until this point, we have spent the year doing a ton of solving. Right? We started by solving equations. 2x equals 10. Right? 1 step, 2 step, multi-step, variables on both sides. We did solving with inequalities. We've done solving for y. Right? We did solving when it was a function and we could plug in multiple input values. We've done solving for x and y with systems of equations. Okay, but we've never looked at what do we do if there's an exponent of 2. And that's what we're going to start dealing with. There are lots of ways to solve quadratics. Okay, there is not a requirement that you have to be able to use all of them. So as we go throughout this unit, there'll be some that you prefer more over others. Okay, that's very common. Okay, and you might decide, you know what, I'm never going to use that option. I just don't like it very much, so that's okay. These first 2 that we're going to look at, though, are our very basic, simple ones that all of my students are like, okay, yes, I can do that. These are ones I want to use. Option 1 is that we can solve a quadratic excuse me, by taking a square root. I think just like anything we look at in the math world, right? Usually it comes with some type of restriction or stipulation that we need to be aware of. Okay, so in this situation, if we're going to solve by taking a square root, obviously it has to have an exponent of 2.
Mrs. McKenny,
Uh-huh.
should I write these notes for Sam?
Nope, it's okay because I'll upload them to Canvas, but thank you for asking. Okay, they must have an exponent of 2. But no exponent of 1. So we can see an x squared, but we can't see an x.
This is the only way to solve it. You have to solve it by taking a square root. It has to make that, but there are other ones.
Okay, so to solve by taking a square root, it's going to have an x squared, but no x. So, like, as we go through, we'll be building up a list of things. So this is sort of like option number 1. And we'll get to like 5 options by the end of the chapter. Okay, so since we can't have an x to the first power, these are going to look pretty simple. For example, x squared equals 9. Now, I told you when we started radicals that order of operations was something that totally annoyed me because it shouldn't really be PEMDAS, but it should really be PERMDAS, right? Because addition and subtraction need to be paired up. Right? Addition and subtraction need to be paired up. Multiplication and division need to be paired up. And exponents and radicals need to be paired up. Because then everything has its inverse operation listed with it. So if we want to solve this for x, we're going to go back to our basic solving equations rules. Right? We'll use inverse operations. We just learned the inverse operation of an exponent of 2 is what? What did we just say over the last 3 days?
What?
What's the inverse of an exponent of 2? A square root. Right? The inverse of an exponent of 3 is a cube root. The inverse of an exponent of 4 is a fourth root. Right? We had all of those. Okay, so if we want to undo an exponent of 2, we will square root. And just like any equation when we're solving, whatever we do to one side of the equal sign, we also have to do to the other. And also, just like every other time that we solve an equation, what do I do with these over here? Right, they just cancel out, it doesn't matter. So when we use inverse operations, these just cancel each other out. So the exponent of 2 and the square root just cancel each other out. Right, 4 squared is 16, but the square root of 16 is 4. It takes me right back where I started. Okay, so those two are gone, which just leaves us with an x. And then here's where things get a little bit tricky. We just have to put one more piece in our brain here. What is the square root of 9? 3, and the square root of 9 has been 3 for however many years we've been learning about square roots. The problem is that that's not the answer to this problem. Here's why. When we say, what is the square root of 25? By definition, it means to take the positive value. However, this problem did not ask us to take a square root. The problem said x squared equals 9. No square root involved whatsoever. Right? We added the square root to help us get x by itself. So if we ever have to add the square root ourselves, we have to consider this fact. What is 3 times 3?
9.
Positive 9. What is negative 3 times negative 3?
9.
Positive 9, right? So 3 squared is 9, and negative 3 squared is 9. But what's the square root of 9? Just positive 3. We're leaving out that other option there. Okay, that's just a definition thing. Not exactly sure why in those situations. So what we want to do is if we add the square root ourselves, if you add a square root, you are also going to have to add a plus and minus. Okay, so in front of this 3, we're going to put that plus minus sign. And this plus or minus sign means that we have a positive 3 as an answer, and we have a negative 3 as an answer. So it's a way of writing two numbers without actually writing both numbers. Here's also a little convenient piece of info. If you are solving a linear equation, you are only looking at variables that have an exponent of 1, which means you have the possibility of getting one answer. If you are looking at a quadratic, you have a possibility of getting 2 answers. If it was a cubic, we would have the possibility of getting 3 answers. So the degree always tells us how many potential answers we can get. Yes, Rachel?
How could we get 3 answers? Because like it's only positive and negative.
We can't on this one because it's a quadratic. It would have to be a cubic.
But like on a cubic, how could we get more than 2 because it's negative?
Hold on to that for a couple days.
Okay.
Okay? Just hold on to that thought. You'll see some other ways that we could solve that open the door for that possibility a little bit easier. Okay? So let's look at some of these. X minus 12 equals 4. So if we want to solve this, we're going to solve it just like we always solve equations. The true way we solve equations is to do order of operations backwards. Okay, so the R really puts a bit of a bump in my SADMEP, right? Order PEMDAS backwards is SADMEP, so this would be SADMREP. SADMREP. Okay, so we're going to go backwards. So any addition or subtraction to undo here. Yep, how do we undo subtracting 12? Add 12. Just like our normal solving rules. Any multiplication or division to undo? Nope. Any exponents or square roots to undo? Yep, how do we undo an exponent of 2? So we said the exponent of 2 and the square root will undo each other. What is the square root of 16?
Positive 4, negative 4.
Plus or minus 4? You'll be really annoyed at me by the end of the unit for all the times I stop and wait for you to give me that plus or minus, because it comes up like every day. Okay, so x equals plus or minus 4. How many answers is this? 2, and what are the two numbers?
Negative 4 and positive 4.
-4 and +4. It is totally acceptable. This is just, like, this is a symbol in the math world. Okay, you do not need to split that out. You would just need to recognize if it was multiple choice and it was as 2 separate numbers, that would be the same thing. This symbol is used all the time. We're going to use it pretty much daily. Okay? Are we okay on that one? Squared minus 100 equals 0. Okay, so let's go down our list. Any addition or subtraction to undo? Yes, so we'll do that first. Any multiplication or division to undo? Yeah, how do we undo multiplying by 2? How do we undo an exponent of 2? What's the square root of 50? No.
5.
No, 5 times 5 is 25.
Wouldn't you get the square root or like simplify it and have like 10?
Oh, look at what we've just spent a couple days doing. Maybe we should prime factor and simplify our radical. Right? So this isn't a perfect square, but we know how to simplify it. So we'd get a 5 square root 2, but that's not our answer yet. Plus or minus? How many answers is that? 2. What's one of the answers?
A negative 5 square root 2.
Right? A negative 5 square root 2 and a positive 5 square root 2? Yes, Rachel?
Never mind, sorry, I did the math wrong.
No,
Sorry.
you're okay? You sure? So just so we understand, right, it doesn't only have to be an x squared. That x squared could be a y squared or an a squared or whatever. Y squared plus 6 equals 4. What are we gonna do first? Subtract the 6 from each side. Then what? Question?
Yeah. Does it matter what comes first, minus or addition, or does it have to be addition then subtraction when it comes to
Nope.
the sign?
Nope, these are on the same level.
So it could be like a minus and a positive.
Mm-hmm. Oh, like when you're writing the plus or minus? Yeah, no. Positive on top, negative on bottom. Okay, so now how do we undo this? Square root. What is the square root of negative 2?
Wait, do we do?
What is the square root of negative 2?
Oh, negative. Is it or 1?
Negative 1 and
Two.
negative 1?
Other two.
Oh my god.
Lucy?
1.
Is it 0?
Is it 2?
Maybe you should flip back in your notes a little bit and look and see when we talked about it before. Instead of guessing random numbers. Maybe put something in your calculators. See if that gives you any memory jogs.
Is it 4?
No. What number times itself gives us negative 2?
Negative.
Negative 2 to negative positive 1.
But you need one negative and one positive. Those are different numbers. Can't do that. Is a negative times a negative ever a negative?
A positive 1.
No, so what's the square root of negative 2?
We can't do it.
We can't do it. So what did we say it was called? No.
No solution.
Oh yeah, no, yeah.
No.
Real solution.
No real.
Right? No real solution because there is a solution. It just falls outside of the real number set. Now that's going to feel really bizarre to you because the only numbers that you know exist right now in your life are real numbers. Which means a number being outside of the real number set is very weird, but there are numbers that you are not aware of that exist.
You okay? You sure?
Are we okay on this one? So if we get a negative underneath the square root, whether it is step 1, whether it is step 2, whether it is step 500, it is a no real solution, NRS. Okay? Pause from that for